we know that hydrochloric acid is very important in the breakdown of proteins in the stomach. So where does it come from? So how do we make hydrochloric acid? Well, hydrochloric acid comes from carbon dioxide. Okay, and carbon dioxide we have in the blood, and it comes into the cell, and this of course is the parietal cell, which we know that makes the hydrochloric acid, and the parietal cell takes in the carbon dioxide and makes the constituents that we need to make hydrochloric acid, which is hydrogen and chloride. So once we get carbon dioxide in here, we have a friend in here that is an enzyme, and that enzyme is called carbonic anhydrase. So we're going to use that same old reaction that we saw in the respiratory system, where we have carbon dioxide and we combine that with water, and that gives us that weak acid, carbonic acid, H2CO3. That H2CO3, and again, this is through the carbonic anhydrase that we have, can be broken down into hydrogen ions and bicarbonate, HCO3. So at this point, from the carbon dioxide, we have hydrogens now. Okay, so we need to get the hydrogens into the lumen of the stomach, and we have a carrier protein or a transporter here that does that, and it takes the hydrogen into the lumen of the stomach. This transporter is actually an active transporter, and it is called the hydrogen potassium Atpase. So we'll say hydrogen potassium Atpase. So what do you think happens from that? We've got hydrogen and potassium. Well, potassium is actively transported in, so that we're kind of trading a hydrogen for a potassium here. So what do we do with the bicarbonate? So bicarbonate is being made as well. So the bicarbonate does not stay in the cell, and it doesn't go into the lumen of the stomach, because that would make the stomach less acidic, right? So it goes back into the blood, or it goes into the blood as the bicarbonate ion. So it goes there, and we actually have another little transporter that does that. And with that, it brings in chloride ions. So we've got a negative ion going out into the blood and a negative ion coming back into the cell. That chloride ion has a channel that will make it go out into, or it will flow out into the lumen of the stomach. Once it's in the lumen of the stomach, then we have chloride and we have hydrogen, and those come together to make hydrochloric acid, or HCl. So that is basically how we get hydrochloric acid in the stomach lumen. Don't forget hydrochloric acid. What do we need that for? We need that for the, when you eat proteins, we get pepsinogen released in the stomach, and when it combines with hydrochloric acid, it is activated into pepsin. So pepsin starts the chemical digestion of proteins. And of course, that occurs in the stomach.